Hey, welcome to Out of Code. My name is Martijn, and what you see behind me here is an example of what you can do with a Truchet effect. I did a video specifically about this effect a couple of years ago, but I thought, you know, why not maybe make another video and see what interesting things we can do. So I made this effect you see behind me here, and in this video I will show you exactly how to make this with only math and programming. So if that interests you, then stick around. All right, so let's go here and let's go and click new over here and get rid of this. And let me just make sure that this is set to large so that everyone can read it if you're sitting in your living room. And then first what I'm going to do is I'm going to do some housekeeping here. I'm going to make it that my UV coordinates are in the middle, and I do that by just subtracting half of the resolution from the pixel coordinate over here, and then dividing it by just the high resolution at y. And I will just make it that my UV coordinate origin is in the middle, and it's also adjusted for the aspect ratio of the screen. And then I'm going to make a black screen like that. And then let's make a function, a Truchet function. So for that I'm going to go, let's go over here, say vec4 Truchet. So Truchet is a specific effect that you make from a lot of similar tiles, and then you flip the tiles in order to make that effect. And this Truchet function is going to take as an input just a coordinate, a position, call it P. And as an output, it's going to give me a color. So I'm going to make a color here. Let's just initialize that to black. And it's going to give a distance as well. And that will become more clear in a minute what that is. And then I'm going to return a vec4 that is the color in the RGB channel and the distance in the alpha channel. And then let's see over here. Let's make a vec4, call it T1 for Truchet1, and let's throw the UV coordinate into that. All right, and then we can let's just first look at the UV coordinate by itself. So I could just say col.rg RGB. What am I doing here? RG equals P, let's say, and that just outputs the texture coordinate as a color. And then over here, if I want to see that, then I have to say col equals T1.RGB. All right, so that gives me my UV coordinates with the origin in the middle. All right, now let's make a bunch of tiles. So the Truchet effect, I said before, it consists of a bunch of tiles where some of the tiles are flipped and whatnot. And so we first need to make a bunch of tiles. And so to do that, I have to, let's first actually go over here. And let's give ourselves a bit more space, UV space, because right now my UVs go from roughly -0.5, -0.5 to 0.5 over there. But let's just multiply that by 5, let's say, to just have a bit more range. Okay, and that just makes my colors more saturated, but that's what that is. And now what I'm going to do is I'm going to cut up the space into the little boxes, and the way to do that is you can just use a fract function for that. So fract just throws out the integer component of your coordinate and just keeps the decimal component. So that will make a bunch of different boxes now. And let's zoom in a little bit. Okay, and then my boxes have UVs going from 0.0 in the lower left corner to 1,1 in the top right corner. Again, similar to how I did over here, I kind of want the origin in the middle and not in the lower left of the box. So for that, I can just subtract 0.5 over there. So now the 0 is in the middle of each box. And now I can use that to start drawing something. And let's see here. Let me, well, let's just use the distance for, shall we? No, let's just use the color for this. So instead of visualizing the UV coordinates, I'm going to visualize something else. Actually, I'm going to use this D to calculate the center, or the distance to the center. Actually, no, I'm not going to do that. I'm going to call it CD for center distance, because this distance is going to be used for something else. So the center distance is just the length of the coordinate. So the length of the coordinate is just the length of the vector that goes from the origin to whatever the pixel I'm at. So this is the distance to center. All right, and I can visualize that. I can say col plus equals that center distance. And then I can see that center distance, and it turns into black for the center of each tile, because the distance there is very close to 0, and that translates to black. And then towards the outside of the tile, it will go to 0.5 on the outside, because my box goes from -0.5 to 0.5. So that kind of makes sense. And now I could use that to draw a disk instead. So I can use, so this gradient, I can change that gradient with a smooth step to make it sharper. So I can say 0,1 or 0.5, and then have the center distance in there, and that will make it that in the middle it's black, and then at 0.5 it goes to 1, and then after 0.5 it stays at 1. And so I can use this to draw a little circle. So I can put these two thresholds closer together to make a sharper circle, and I can also turn them around. And if I turn them around, meaning that the second one's smaller like this, then I have the white in the middle and the black on the outside. Now, right now, I'm controlling the radius of the circle and the blurriness of the edge with these two numbers. Now, I don't like that. I want to separate that out. And so what I can do is I can just subtract 0.5 from all these three parameters at once. So if I subtract 0.5 from here, and I also subtract it from here, so then that would be like minus 0.3, and then over here that turns into 0. So now nothing has changed, but now I have the blurriness of my edge is now in here, and the radius is here, and they're separate from each other. So let's just make the blurriness, like, call it W over here, so that I have more control over this. So I can say float W equals 0.01, let's say, and this is the edge blur. Okay, and now I have that, and now I have my radius is independent from my edge blur, right? So if I want to change it to be a more blurry circle, and I want to change the size right now, that's just independent from each other, which is what we want. Now, I don't want to draw a disk, I want to draw a circle. And to do that, if we just look really quickly at this once more here, at CD. So I go over here, CD. So that was the distance from the center, right? And now what I did by the -5 is just change it so that like right now 0 is in the middle, but if I subtract 0.5 from it, then the 0 is going to be at the edge, right? So if I do this, it's going to be really dark. But like now, yeah, if I just multiply that, you can see it a bit better. Now the 0 is at the edge, and it goes negative in the middle. But if I put an absolute around that, then wherever it went negative, it still goes to positive, right? So that's how you kind of fold things around. And now I can use this and put that into the smooth step to make a circle instead of a disk. So let me just go back here. And then, so this is where we were, minus this one. and I'm just going to put an absolute around here. All right, and that makes me an infinitely thin circle. The only reason why I can see that circle right now is because the blur makes it kind of slightly thicker. But in order to get the thickness of the circle, I can just subtract from here now in order to get something. Okay, so I hope that makes sense. So now let me also visualize the edges of all the tiles. So for that I'm going to do if p.x is larger than 0.49, let's say, then or p.y is larger than 0.49, and this is just for debug purposes. Then I'm going to make it white. So now I have these lines at the edge of my tile, so we can see a bit better what we're doing. Now we have this circle, so I'll make it a little bit thinner and also a little bit sharper. Okay, now in order to make a Truchet, the simplest Truchet effect, we want to put this circle. So right now the circle center is in the middle of the tile. I want it on the corner of the tile. Okay, now how do I do that? Well, I just have to remap this value here, this p value here. Because here, this just calculates the distance to the center, but I need to calculate the distance to a different center, right? Like a center that is centered on the corners. And to do that, I can just go over here and remap this p value to a different place, right? So if I subtract 0 and 0 from it, obviously it doesn't do anything, but if I subtract anything else from it, you can see that I can move that circle over now. So I can move it to 0.5, which is right on the edge, and 0.5, which is also right on the edge. So now my circle is centered on that point over there. Now I want to make a second circle in the lower left corner. So now what I could do is I could just copy this entire thing with different coordinates. Then instead of minus over here, I just put plus, right? But that's a lot of code for just one character different, right? So there's a smarter way to do that. Because let's say we have this value s, and let's say the value right now is 1. Now if I multiply this offset here by s, right now nothing happens. But if I set this to -1, then it gives me the other side, right? And so now all I need to do is I need to make sure that this s value evaluates to 1 for all pixels that are in the top right corner of my tile, and evaluates to -1 for all pixels in the lower left corner of my tile. So now how can I do that? Well, it turns out to be not so difficult, because I can just use my coordinates for that. So my coordinates over here, they're 0 in the middle, and then they go from -5 to +5, -0.5 to +0.5 in the x and in the y direction. And what I can do is I can just say, well, if the x coordinate is larger than the y coordinate, then make it 1, otherwise make it -1. Okay, and let's just visualize that real quick. So I go over here, say col plus equals s, and I can see what I'm doing. And actually I still want to see my circles as well, so let's just multiply this by 0.5 so we can kind of see something. So now I have the s value is 1 if it's in the lower right half of the screen, and it's -1 if it's in the top left half of the screen. I want that triangle to be flipped, right, along the diagonal. And for that I can just put a minus over here and it will flip it. And would you look at that, now we have 2 circles for the price of 1, right? So now we have this. And now to finish the Truchet effect, all I have to do is make it that random tiles can get flipped. And how do I flip a tile? Well, I flip a tile just by flipping the coordinates. So I can either flip the x or the y coordinate, it doesn't really matter. So let's take the x coordinate. I can just say if I multiply that by -1, then it will flip it. And actually I have to make sure that if I do that, I do that before I calculate my my s value here. So this is the corner selection, right? Corner selection. So I have to make sure that I do that before, otherwise my corner selection is off. All right, so now I have it flipped, and now it's flipped back. And now I just have to make sure that it does that at random, okay? And how do I do that? Well, I need to first get a random value per box, okay? And so before I do that, I have to know which box I'm in. And for that, I'm gonna make an ID value, which just takes the floor of the original coordinate, okay? So here it's the fract. So the fract leaves only the decimal part, the floor leaves only the integer part. Okay, so floor plus fract is the whole number. Fract is one part of the number, floor is the other part of the number, kind of. So this ID value will now be different for each box. Okay, but every pixel in the box will have the same ID value. And now we can use that ID value to calculate a random value. So for that, I'm going to make another function that's going to return me a random float between 0 and 1. And I'm going to call that hash 21. And the 21 is just to indicate that it takes a vector 2 as an input and it returns a float as an output. So it's two values as an input, one value as an output. I'm not going to really explain this, but like there are multiple ways to do a hash. This for the 2D hash, this is my favorite one. It's just the fract of p times some larger vector with some decimal values, and it really doesn't matter that much, those numbers. And then I'm going to say p plus equals the dot product of p and p plus some other value. And this is just some screwing around to make it that it looks random in the end, even though it's not really random. And I'm going to return the fract of p.x times p.y. Okay, that gives me a pseudo-random value. So let's make that here. So I'm going to say float n equals hash 21 of ID. And so this is a random 0 to 1 per box. All right, we can visualize that as well. So I can just go over here and say col plus equals n. Okay, and that gives me different grayscale values for each box, and that tells me that those are the different random values. And now I can use those random values to start flipping tiles, right? So I can go over here and just put an if in like before this. So I can say if n is smaller than 0.5, then flip a tile. So now that will flip half the tiles, roughly. Okay, so now I have a beautiful Truchet effect. Let's just zoom out a little bit so we can see what it looks like and get rid of the edges. All right, so that's pretty neat. Now I was playing around with this, and I thought, because like, there are many different types of Truchet effects. This is the simplest one. It's called quad Truchet because the tiles are quadrilaterals, right? They're all like little squares. There you can make Truchet on any kind of tiling of the plane. So you can have triangular Truchet or hexagonal Truchet or what have you. And so I was playing around with it, and then I was thinking, well, what if I take two of these and I try to weave them together? So let's try to do that. So for that, first what I'm going to do, because both of them are going to have different colors, so I'm going to add a color to this. So here I'm going to make it red, let's say, and I'm going to go up here and I'm going to say vec3 col, and then I have to take it out here. So then I have a color, and then I have to check what it's going to do. Yeah, okay, so that's not what we wanted. And then here I'm going to have to, I suppose, multiply it to get that. And then I could still have the edges of my tiles. Okay, let's make this a bit bigger again. All right, so that's my red Truchet. Now let's try to make another Truchet. So I'm going to copy this here. And I'm going to call that T2. And let's make this one green. All right. And then let's just add it for now. So plus equals T2.rgb. All right, and that makes it yellow. You might think that's kind of weird, but that's just the red one and the green one that are exactly the same at exactly the same location on top of each other. So full red plus full green makes full yellow, and so that's what you're seeing here. But now what I'm going to do is I'm going to offset the second one, and I can do that by just offsetting this UV coordinate over here. So I can, like, if I just add something to it, you see it starts shifting it. And how much am I offsetting it? Well, I'm offsetting it exactly by half a tile. So now they are together like that. And if I take this out, then you can already see where this is going, right? So now these are on top of each other. Now what I want to do is I want to make it that at every intersection, only one of them is in front, right? In order to get a nice weave. So how can we get that? Well, let's first go back to just one of them, and let's put the edges back on. So what I want to do is I want to make sure that at every, so if we just look at this one tile over here in the middle, at every edge where the circle touches the edge, either it's under or it's over, right? So it's either under or it's over. And so what I'm going to do is I'm going to use a polar coordinate to calculate that. So a polar coordinate is just, so let's say this circle over here is on the corner here, right? And what a polar coordinate is basically, it's just an angle around the clock and it's a distance. But like I want to calculate the angle around. So, and to do that, I can use an arc tangent for that. So let me go over here. So first what I'm going to do is I'm going to take this out here, and I'm going to call this CP for circle position, and I'm going to say vec2 CP equals this, right? So this is the well, it's the circle coordinates, really. Circle coordinates. Okay, so that shouldn't change anything, right? It's the same thing. And now I've done it like that, so that now I can calculate an angle. Okay, and for that, let me just go over here. Let's just get rid of this, and let's go over here. And let's say float A for angle equals the arctangent of cp.x, cp.y. All right, and we can visualize that real quick. We could say col times equals, although you have to realize that this goes from, so this is the polar angle from minus pi to pi. Okay, so we can try to visualize that. I could just multiply it like this, and then you get something, but because it's from minus pi to pi, that's not really good. You want it to go from 0 to 1, really. So for that, I'm gonna just throw this into a trig function, into a sine. So that sine already will make the output between 0 and 1, and then I'm gonna change that to between 0. No, let's say it again. Like the sine will give an output between minus 1 and 1, and then I want to get that between 0 and 1, and the way to do that is just go times 0.5 plus 0.5. Okay, well that doesn't really show us too much yet, although one thing that I can see here is that, so this goes all the way from 1 to minus 1 over there, but that takes 2 tiles to get from 1 to minus 1, and that's not what I need. I need it to go from plus 1 to 0, like right there, right? So it needs to go twice as quick, right? So well, for that, I can just multiply this by 2. So I can do times 2. All right, then I have that. But now it seems like the top is in the middle, and then here it's only halfway down, and here it's halfway down. Like, so we don't want the top in the middle, so we can shift the top over, And the way to do that, you could just add to here to change the phase, and then you could slowly move it. But you can also just make it a cosine, and then it should also move over. Yeah. So that's exactly the offset that we need. So now we have all of these, like they go from 0 to 1, and 0, 1, 0, 1. So let's turn this off. Okay, and now let's get the other one back in, and let's see what that does. Would you look at that? How neat is that? So now we kind of have a weave going on, which is pretty cool. So now let's try to make that a little bit cooler, perhaps. So the first thing is that, well, the weave works right now because it goes all the way to black. Like when it's in the back, it goes all the way to black. It goes to 0. And that's why I can just use an additive blend over here. I can just add the two together, and it will make a proper blend. But if this doesn't go all the way to 0, then I'm going to have a problem. So yeah. So the reason why that happens is because over here I calculate the shading, right? So this is the shading, pretty much. Where do I have my D value? Okay, over here. So let me take this, because this really is the distance, right? Or it's the, like, how far away, how deep you are. It's the depth, kind of. So let me just take this out and I'll put that over here and call this the depth, And then I can use the depth for shading, right? That's fair enough. I could just use that. All right. Let me see here. Yeah, so now the depth goes all the way to 0, and that's why the color goes all the way to black. So if I don't want that to happen, I could use a mix, for instance, to say, instead of going from 0 to 1, so this is what we have right now, I could say, well, I'll never get completely black, right? Let's say like this, right? But now you have the issue that that when they overlap, you see that they're kind of, you can see the additive blend, which is not what I wanted. So for that, we could just use the depth value over here, because here I could say if t1.a, which is the depth value, is larger than t2.a, then yeah, anyways, like, I don't know exactly how it is here. I guess we're going to have to experiment a little bit. If one is larger than the other, then show it. Otherwise, show 0. And let's see here. What did that do? Okay, over here, I'm going to have to say vec3, 0. Okay, and that's not what we wanted, obviously. So let me do it the other way around. Oh yeah, of course. So yeah, so this depth value also has to be multiplied by the contour. So here, this is really the contour of the of the swiggle itself. So let me just call this the contour. So float contour equals this, and times contour. But I need to multiply both of them times contour, so I could just take this out over here, and because the depth value also needs to be kind of masked out. So times contour. Okay, and now let's turn this around again. Okay, so now we have something. And now over here, plus t2.a larger than t1.a. Then show t2, otherwise, or add 0. There's probably neater ways to do this blending, but that's how I'm going to do it right now. So now we have two squiggles that are that don't have to go completely to black, which is pretty neat. All right, so what else can we do? Yeah, so what I what I often like to do is like whenever you use a distance, right, a length here, and you use distances a lot inside of shaders for a lot of different effects. When you use a distance, there are different types of distances that you can use. So this is just Pythagoras, right? It's like x squared plus y squared, and then the square root of that. Let's just make our own length. Let's just recreate it, okay? So instead of a lowercase here, I'll just do it with an uppercase, and then let's just make a length function over here. So float length takes as an input a vector 2, and as an output it gives me a length, right? The length of the vector. And how does that work? Well, that really is the square root of p dot of the x squared plus y squared, and then the square root of that, right? So that's what that is. And if I compile this, nothing changed because this is exactly what length does. Now let's rewrite this a little bit. So this here, p dot x times p dot x. Well, you can also write that as this. You can use the power function for it. So you can say pow, and then 0.2. Okay, and here also pow and 2, right? And then the square root of that. So now if I compile that, still nothing changed because it's still essentially the same thing. Now the square root, I can also get rid of that by using a pow, because I can just say pow, and then over here I can say the inverse. It's to the half power, right? So again, nothing has changed here. But now a cool little pattern is shown here, because I see this 2 here three different times, right? So let's take the 2 out, and let's just call it k and k. And then over here, if I say float k equals 2, then still nothing has changed, right? But now I can change this to other values. I can say to 4, let's say, and see what changes here, okay? It changes the shape, which is really cool. Now I didn't go to an odd one, because odd ones kind of break. But the way to fix that is you just have to make sure that all values are positive. So I can just say p equals the absolute of p before that in order to fix that. And now you have much more control over the shape, because you can also make it smaller here, and then it makes it straight. And you can even go smaller than 1 to get concave shapes. Anyways, this is something called Chebychev distance, and it is for generative artists. It's a very good thing to know about, because anytime you use a length, you could use this length instead. So let's expose this k value, and let's go down here where I use my length and call that curve, and then pipe in the curve from here. So I could say float curve. And now I have to go all the way down here to where I call the Truchet function. I could say with 2 and 2, so that is the standard one. But now I can change them, right? So now I can make one of them, let's say, more square than the other. And what I like to do was keep one of them totally round and make the other one totally square, so that you have a round and a square, where the round one is kind of wrapped around the straight one, which is pretty cool. Now I also want to expose the width, the thickness of these Truchets. So for that, I'm going to just get rid of the space here and call this float thickness. And the thickness was over here in the contour, over here. That's the thickness, right? So I can put that in there like that. And now over here, I can say 0.03 and let's say 0.08 to have different thicknesses for both of them, right? So now I have control over, over the thickness. And yeah, you can do kind of neat things with that, because like this doesn't have to be a constant. This could also be changed by, driven by something, right? For instance, let's drive it by the position on the screen that it's at. So let's get the center distance here for center to the screen. So for that, I could just do whatever the length of UV, or the Chebychev length if you wanted to. So if you want to play with that, then you can change it and see what you can come up with. So that's the distance to the center of the screen, right? Distance to center of screen. And now over here, I could call this W for width, and I'm going to say float W equals, I can use a mix. I can say, well, at the edge of the screen, I wanted whatever 0 width. Well, here, let me do it the other way around. So like in the middle of the screen, I wanted 0.1. At the end, I wanted 0. And then I can use my center distance. But I'm going to first use a smooth step to remap it. So smooth step, and I'm going to say CD, and let's go from 0 to 0.5. Let's see what that does. Okay, so now you see that we have it thick in the middle, but it goes thin towards the outside, which is pretty cool. So maybe in the end I don't want it all 0, like completely gone, so I can do something like that. And you can shape this however you want. All right. Okay, so now another thing that I wanted to do was make some pattern onto this thing. So yeah, and the way that I can do that is I can use my polar angle to put a pattern on this thing. So because what I could do, for instance, over here, I could say col times equals the sine of the polar angle times 100, let's say. So now we have a sine that goes very quickly along the circle, right? Let's see what that looks like. Okay, so maybe that's a bit too much, so let's make it a bit smaller or a bit less. Okay, so now you can see you can make like different effects with that, right? Now, one thing is I don't want it on both of them, I just want it on one of them. So for that, I'm going to make expose in this Truchet another variable, call it pattern. Okay, and then I'm just going to multiply that by pattern over here. Yeah, so I'm going to have to say multiply this by 1 plus this, right? And then here, if I multiply this by pattern, and pattern is 0, then the whole thing just gets multiplied by 1, meaning that nothing changed. Okay, so that's kind of how that works. And so now I have my Truchet 1 and my Truchet 2 over here, and I can say, okay, the first one is the squiggly one, and I want a pattern on that one, and the second one is the straight one, and I don't want a pattern on that one. And then I can do it like that. Okay, so now let's try to make kind of a cool pattern. So what I'm going to do is I don't want it to go all the way to black, so I'm going to multiply this by some smaller value just to have it like that. And then I want some pointiness in this as well, and for that I can offset this, like change the phase of this based on how far from the center of the squiggle it is. And the center of the squiggle is what? The center of the squiggle is this over here. So let's cut this out, Control X, call this ED for edge distance. Go over here, edge distance equals this. So this is edge distance. And so that hadn't changed anything, right? Except for over here I had a plus. So this is where we were. And now I can add this edge distance so that the farther away you are from the center of that squiggle, the more the sine phase changes, okay? And so right now you probably won't see anything because you need to multiply this by some large number in order for it to be visible, all right? So now we have a direction here. The only thing is that the direction changes for every tile, right? On every tile border, the direction flips. And that's logical because we flipped the tile. And so yeah, but I don't want that. I want it to be the same direction everywhere. And so what I have to do is I have to flip the pattern for every other tile. Okay, and so first, in order to get to every other tile, I need to make a checkerboard. And to make a checkerboard on a 2D grid, you can use a modulo, and you can say we can use the ID value, id.x plus id.y, and then modulo 2, and that will alternate on the x and on the y, and you combine it together, you get a checker. But this will alternate between 0 and 1, and I want it to alternate between -1 and 1. So for that, I'll multiply by 2. So now it alternates between 0 and 2, and now I subtract 1. So now it goes from -1 to 1. And now I can go, we've got to figure this out here. Probably just multiply that. Okay, and that flipped around some of the patterns to have it in the same direction everywhere, which is pretty neat. And now we can also move this. So I can just, if I add itime to this, it's moving. Okay, maybe I want to move it a bit faster. So let me just, first of all, also move it the other way. And then let's times 5. Yeah, something like that. That is pretty neat. Yeah, well, I think that's kind of it. Let me just move this so I can do uv plus equals itime times 1/10, let's say, just to move it. Okay, I have to do that after I calculate the center distance, because otherwise it calculates the distance to the center that like moved away, right? Which is not good. That's why all of them are thin right now. So I have to do that after. So that always in the middle, they get thicker, and towards the outside, they get less thick. All right, I think I'm going to leave it here. As you can see, there's lots and lots of things you can do with Truchet effect. I implore you, if you made it this far, to explore this more. Try different distance metrics, like I showed with the Chebychev distance. Try different tilings. Okay, this is a quad tiling. What about a triangular tiling? What about a hexagonal tiling? What about some exotic tiling that isn't regular? You know, like that. You can really explore very deeply with this, and yeah, it's fun to do. So anyways, if you made it this far, I take it that you get something out of my videos. If you want to support me, please consider becoming a patron, or consider purchasing one of my NFTs. So I started in the last couple of videos making NFTs from all of my effects. So it's just another way that you can support, you know, like a YouTuber. So if you want to do that, link is in the description. Anyways, I think I think that's it. So thank you very much for watching, and I hope to see you next time.